Hi everybody, welcome to our lab. This lab is really about the basics of electricity and in particular direct current, which is similar to biochemical current, like you have a potential difference and the electrons flow from point A to point B, not back and forth like alternating current. So there are other parts that I've had to this lab before, like making a battery out of acid and lemons and stuff like that, but I might save that for the next battery. Another thing that this lab is designed to do is really just to teach you how to use the multimeter so that you're prepared for the next lab in which we do use the multimeter. A multimeter is basically a device that allows you to measure voltage, resistance, amps, current. It allows you to measure many things. And now since you're online, you're not going to really be able to use the multimeter, but if you go out and get one or look at one, you'll sort of know how it works now. And you'll see some images as we do it here. So this lab has a few parts, and actually part one, station one, is really just to teach another life skill, which is soldering. Now you won't be able to do this one in the online classes, but in the face-to-face class, what we're going to do is we take a wire. I just have a little piece of red wire here, and I strip the ends. So teaching you how to use wire strippers. Very simple device. You just clamp on the right size gauge and then you just rip the strip off. You can see now I've got a little bit extra wire here, and that's to take the rubber coating off of these wires. Then I take the wire and I wrap it together to basically create a junction, like if I was bringing two wires together. Now we can do this normally with you have little ends that you screw on to wires. Normally when you bring the wires together, you would depending upon the gauge or the size of the wires, you would screw the little caps on, and that would create a connection between them that would be stable. And I'll even go so far as usually to electrical tape around that. But the purpose of this lab is, first of all, to show you how to strip wires, how to use wire strippers, but also how to use soldering iron. So I've got my very old Radio Shack soldering iron there. And it's a triggered one, so you press the trigger and it gets hot pretty well, and I've got my solder. S-O-L-D-E-R, solder. And once you solder a joint, solder something, it melts at a very low temperature, but it's pretty stable and it can hold things together, and it conducts a current. So you can hold wires together with it in such a way that they will conduct a current. Now I messed around a little bit here to figure out how to do this without a clamp and just by myself, but you heat the soldering iron up and you can put the solder directly on the gun. I don't like doing that. I prefer to heat up the wire. So I press the trigger on my soldering gun once I get this kind of arranged, and I finally figured out, hey, I can just have it sitting on those wire trimmers, and I just melt the solder onto the wire. So I'm holding the solder and I'm holding the soldering gun on the wire and I'm melting it on. Now that wire was copper, so it had a reddish hue to it. And what you're going to notice now is you can see that that solder has been melted onto the wire. You can see that silvery glaze in with the copper. And it's really just that simple. I want people to at least use a soldering gun once. And you can see I can try pulling it apart and it's held together now. So that circuit has been completed. I tried to bring the camera a little bit closer so that we could get a better view of it, because I wasn't sure when I was shooting the video at first if you were able to see the solder, but you can, I think, see that there is solder on that wire. If you look at the other side, there's no solder because I didn't solder that side. I soldered that side. So in the classroom, everybody has to, in pairs of two, solder some wire together and show me that they've succeeded in doing that. So that's really what part one of this lab is. Online students aren't going to do that. Part two is learning how to read resistances. Now, resistors can have many different sizes and shape, and the size and shape of the resistor doesn't necessarily tell you how strong that resistor is. So we set our multimeter, and I have several different multimeters, but we set our multimeter to the little ohm, and that ohm is for measuring resistances. And you can see that's a small one. And actually, if you understand resistors, those little color bars on the resistor also tell you what the resistance is. But many newer resistors Well, actually, if it's big enough, and it takes it a second for this to come into focus, it's actually written directly on the resistor what it is. And that one's, once I get it to focus here, 50, was it 50 or 42? 52.3 ohms. Now that's not actually what I got when I tested the resistor. So either the resistor's off or I need to recalibrate my multimeter. So that red box there is a multimeter. It can read many things, and you have a positive and a negative terminal on it. I'm switching sides here. And you actually switch the red terminal depending upon how many amps you're dealing with. Now with the resistor, what I want you to notice how I'm touching it with my fingers. My fingers will give much more resistance because it has to go through my whole body than the resistor was. So what you can see there, and I'm going to try and pause it. What you can see is that it's reading about 12 ohms. And I can't remember at this point if it was reading ohms or kiloohms or what. Hopefully I'll get a clearer view here when it comes up. But I'm holding the wire where it's going. But the problem is the current is not going through my hands, it's going through the wire, and my fingers aren't inside the wire. So I can't break that circuit. So even though I'm touching it, and I'm going to prove this when I do the last one, you'll see that it doesn't change what the reading is on the ohmmeter. So this is a multimeter, and when you're reading resistance, it's actually you can call that an ohmmeter. So that's number one. That's resistor number one. That's what you're going to write. So all you really are doing for the online students is just writing this down, but I'm letting you see this. Now, why did I scratch that there? I noticed that there was a little bit of corrosion on the wire. I steel wooled them a little bit, but not perfectly, and I want the resistance to be the resistance of the resistor, not the current trying to pass through the rust. So here's number two. I just connect it to the resistor, trying to get a good tight connection there with it facing the right direction. And you can see this resistor, it's a lot bigger, but it's not necessarily a huge number. It took it a while to settle down. And there we go. Notice it's bigger, but it actually has a lower reading. Size doesn't necessarily mean the resistance. And this one was a 4 point, whatever you want to put, somewhere between 4.8 and 5, depending upon what you got. So we go to number three. And I covered this one up because normally you read 1, 2, and 3, and number 3 is actually written on there what it is. So it took me a while to get this one to settle down. And I got about 4.3, 4.34. And that one was actually written on it. So that's 1, 2, 3. Those are the ones that you had to do. But I wanted to show you a couple of other resistors just to show you that they come in different shapes and sizes. So I went ahead and I read this one, number 4, connecting its ends. And that one is a very strong resistor. It's 200 and something once it settles down. And I believe it's supposed to be a 220, but it was reading around 210. 214, 215. You can see how that is giving me a pretty good reading there of the number of ohms. So it's much bigger, but that's not why, because here's another bigger one. And this is one where I'm gonna take my fingers off of it. I'm gonna wrap it around just to show you that whether my fingers are touching it or not, I get the same resistance. Trying to pull them apart there. So I get about, remember this one was supposed to be 52, and that's not the resistance that I was getting, but this is an older resistor. Who knows, maybe it was labeled wrong. So it's supposed to be 52, and I'm getting around 58 to 60, so I'm getting higher than I should. But I'm just showing you that even with my fingers on or off, it's not making a big difference to the readings. So that is resistors. And just to show you what they look like, and they can be really tiny, like microscopic too. It's just something that impedes current so that you can alter voltage or amps depending upon what your needs are. And we'll talk about that in the notes, like why you would need to change volts and amps, how volts, amps, and resistance are related. That's Ohm's law in the notes. So now we go on to part 3 of this lab. And here we're going to set the multimeter to DC volts, 15, or just DC volt depending upon the multimeter. And what we're going to do is we're going to tell whether or not these batteries are any good. The typical battery is like a AA or a AAA, or a lot of battery cells are 1.5 volts. And when you put multiple batteries in series, you can increase that and do 1.5, 3, 4.5, 6. It just depends upon how many volts you need. And in fact, one of the first things I'm going to do is first I'm just so a different multimeter here. I'm going to show you this 9-volt battery that I have right there in the middle. Once I show you that I have this on the volt DC setting, and actually this one is volt DC AC uses the same setting. So it's a little fancier one that I have. First, I wanted to show you what a 9-volt battery actually is. You know those rectangular batteries? It's a 9-volt. Well, what it really is 6 1.5-volt batteries that are in series. Kind of like quadruple A if you want. They're like really tiny batteries, and they're stuck in there. And if you take it apart, all of these little batteries are inside of it. And when they're combined, they give you 9 volts. Now, I'm going to start with, there are 3 AA batteries. Okay. Now, for whether or not this battery is any good, just read this first one. Is this battery right here good or not? If I use the volt setting on my multimeter, it should give me about 1.5 volts. If this this is voltage 2. So what do you notice about the voltage reading on this battery? So on station 3, this is what I want you to put for voltage 2. Notice how it's like jumping all over the place. I had trouble getting a good setting. Every now and then I could get it to be 1.57, which would suggest that that battery was good. But it's clearly not. There's some kind of a short in that battery. So that's voltage 2. So let me rewind it just a little bit so that you can try to find a setting for that battery that you want to. So there you see for like a split second I had a 1.57, but then I had a 1.034. I had lots of different settings for that battery. And I'll pause it and you can like pick a few of these. So there's a, that's actually a millivolt, so that's MV, so that's 69 millivolts. So that's not even 1 volt. And then you got 50 millivolts, and then it goes up to 1.6. It's all over. Just pick one of those numbers to put in, but clearly that battery is no good. Now we're going to go to voltage 3, and this is a 9-volt battery, and we'll see what it gives us. We'll see if this 9-volt battery is any good. And we get 8.98. I mean, that's pretty close to 9 volts. Now, most 9-volt batteries that I test usually read a little bit above 9 volts. So that tells me that that particular brand has a little bit more internal resistance. So we're getting a little bit lower, but it's probably still good. Now, the size of the battery doesn't really have anything to do with the voltage. This is a C cell. So this one is not one of your voltage 1, 2, 3 readings, but I just want to show you that even though it's bigger, it's still about 1.5 volts. It's actually reading 1.6, so that one's a little bit overcharged. So it doesn't matter what the size of the battery is to tell you what the voltage is. Okay, so by now you should have voltage 1, 2, and 3. 1 was The very first battery, voltage 2 was the third battery, and voltage 3 was the 9-volt battery. So let's do two of the bigger 6-volt batteries now. So you can see these are huge, but they're only 6 volts, and these are larger lantern batteries. So here's number 4. Remember, it should be 6 volts. And I got not too bad. And here's number 5. So that's your voltage reading for number 5. And what I want you to notice is, let me get in focus here. I'm pushing down onto the leads. If I was to somehow touch the 2 leads, I would mess up the reading, and we don't want to do that. So that finishes up our station 3 voltage readings, and we then go to station 4. So in the lab, I have 5 stations set up, and you go from one to the other, and you do this lab. Now this one, I've included sound. Oops. I've included sound on this one because if you do your, let me try and stop it when it's in focus. There's a little sound setting, and what that means is if I have a signal, I will hear a beep. That means that it's a complete circuit. If I hear a beep, I have a complete circuit. And if a light has gone bad, the circuit is no longer complete. And I won't hear that beep. So it's a good use of these devices that you hear a beep when you have a complete circuit, and you can find where a break is in a circuit when that beep goes away. So we're going to test these light bulbs and see if they're good by listening for a beep. I could also just read their volts, but I'm not going to do that. So I also want you to notice there are like lots of different kinds of light bulbs out there. Now here I'm going to touch them together just to show you that when there's a complete circuit, you hear a beep. So we hear a beep, the circuit's complete. Now here's battery number 1. I touch one part. Now it's very important, let me get it focused. So my finger is holding the electrode on it. It's very important that my finger not complete the circuit either. So this black part on the light bulb, I can't have my finger on that. My finger can be touching one or the other electrode, and at the very end of the light bulb is one of the electrodes. So you can see with this light bulb, no sound. But if I touch them together, there's a sound. And I'm getting no reading on the multimeter reader. So here's I just love the way this battery looks. Is that one complete? So does that bulb have, and it's called continuity. And there's definitely continuity there because you hear it. Now here's another neat battery, and I'll bring a background here so that you can see that the positive and negative are actually on there on different sides of the glass. So you can kind of plug these types of light bulbs in very, very quickly. Just pull them in or push them out. And let's see if this one's any good. This one's kind of harder for me to hold in place without completing the circuit with my fingers. So you can see that it's good. So I'm going to go ahead and show you 2 other types of light bulbs here too. Well, actually that's just first a flashlight bulb, cheap little flashlight bulb. That's not one of our tests. This one I believe is no good. I can't remember. I think this was a no good battery. The next 2 are, nope, that one, yeah, that one's no good. You can see there are lots of different types of batteries. This is a car headlight. I can't remember if that's a turn signal, or I can't remember which one that is. But you can, it's not complete when I touch the 2 electrodes, and I'll bring you up close to see that, so you can see that there are just 2 little pins in there that you slide into place. So those are light bulbs and continuity checks. The last station is to show you that when you put things into a series, when you create a circuit and the circuit is in series, notice how the wire runs in a series. It goes up, across, down, across, up, across, down, across, up, across. And I have 5 light bulbs in series. And when things are in series, when they are in series, remember that you can add uh, uh, the resistance from one to the other. In series, you add resistances as you go. Now, I didn't point it out, but the multimeter is set to read ohms right now, so resistance. And I'm gonna measure the resistance across one of the light bulbs. Whoops, didn't mean to, wrong button. So I'm going to measure the resistance across one light bulb once I realized I didn't open up my probes. So this is a different multimeter. It looks the same, but it actually has different probes on it. And I just want to take the caps off them so it's easier to push these things in there. So we're there. I'm pointing out that I have it set on resistance or ohms, and it's not on the sound one, so it'll give me a reading here. I had it backwards, so then I'm going to put it in the right direction, negative to positive. And we see that we have, once this settles down, about 6.3 ohms. 6.4, 6.3, probably somewhere around 6.4. Now what I'm doing is I'm extending my circuit, but I'm not going to the next light bulb. I'm going right before the next light bulb. So the reading went up just a little bit. Now it's 6.5. It was 6.4. And that's just to show you that there is a little bit of resistance in the wire itself, but not a lot. Now, if these light bulbs are the same, remember that you add the resistances in series. So if I have 2 identical light bulbs and I'm just adding the resistances together, it should be 2 times that for the next light bulb. So let's see what happens when I cross over to the other side of that. So we're expecting it to be around 13. And if it was 6.4, 6.4 times 2, 12.8. It is twice as much. So now I can go to 3 or all the way to 5. Now 5 times 6 would be 30. 5.4 times 6. So you add that 0.4, 2.4. So around 33 is what we would expect it to be. Notice how it's a little bit higher. So why do you think it's a little bit higher after what I've said? So it's not just multiplying the 5 batteries together. So I'm not going to tell you that answer because I've given you all the answers already. So it's basically just filling out this worksheet. And by filling out this worksheet, I know that you've watched this video. And I hope that that has taught you something about the instruments that we use, basic instruments that we use for measuring ohms, a little bit Ohm's law, a little bit about continuity checks, and how to do some soldering. I hope you found it interesting. And ask me, you can email me if you have any questions.